This is the third video in the amortization video series. If you haven't done the first two videos and your workbook doesn't look like this, then you need to stop this video and go back and complete the first two videos. Alright, we've finished the first half of the data section up here. We've finished now our amortization table. Now we're going to finish off the data section. What we're going to do to finish this column is take a look at this table and bring some values up to our data section for evaluation. So we have the term of the loan that we've measured in months the way it should be if we make the regular payments. But what we want to do is figure out what the loan length in months actually was given our payment schedule, any extra payments that we made. So we'll just take a look at the number of payments that we made. It's keeping track. Every time we make a payment, when the loan's paid off, it goes to blank. So the largest number in this column will be the number of payments that we made. We know that we copied this down to row 2614. So I'm going to go ahead and get the maximum value of the values beginning at C15 colon and going to 2614. Close that. And there, 283 months payment. One payment was made each month, so 283 months. Now for the loan length in years, what I want to do is show you how you can use an if statement in an equation as part of an equation. In this case, we're going to use the if statement as a part of the denominator in a little division problem. But first of all, we have two scenarios here. Remember, we have this workbook checking to see if the payment period is years. If it's years, it's leaving off a couple of lines here because we don't want to be redundant. Have this say years to break even, this say years to break even, this say loan length in years, and this say loan length in years. We want to take one of those out. You'll notice if I change this to years, you can see this is gone, this is gone. So if this is yearly, we're going to want to just leave this blank because this will have calculated the loan length in years. It would have gone out and gotten the maximum number. However, if it's anything but yearly, then we have to do a calculation. So let's set it back here to monthly. Let's do our calculation. I'm going to use an if statement. If, and I'm going to take a look over here again, the value in D5 equals, in quotes, yearly, then I'm not going to do anything because I've already calculated in the cell above. Otherwise, I'm going to take the value in cell G5, which was the loan length in months, and I need to convert this to years. So I'm going to put it over, and then my if statement, if, take a look at D5, equals weekly. Let's just go through our list. Then it's going to be over 52 weeks. Otherwise, if D5 equals biweekly, then it's going to be over 26. Otherwise, if our value in cell B5 equals monthly, then it's going to be over 12. Otherwise, it will be over 4. We've already eliminated yearly, so once we get to quarterly, we're there. I'll go ahead and balance my parentheses. There we have them all. Press enter, and I get the calculation for the loan length in years given our additional payment. The total amount paid on the loan, what we can do is do this a couple of ways. We have cumulative principal paid, cumulative interest paid. So we could take the max of this column and add it to the max of this column. or we could take the sum of this column and add it to the sum of that column. Either way. So to do that, I'll put sum, and I'll begin with my interest paid, colon. Then I'll take that out, and I'll go over from D, I'll go to E, because I can sum two columns at the same time. And we went down to row 2,614, and that will total up every amount that we paid and give us the value. That's how much we actually paid on the entire loan. The total interest paid, we'll just do the same thing. We could either, now at this point now, let's just do this. Let's take max. We'll use the max this time. You know how to use the sum, so let's cumulative interest paid. Place our cursor here, and then colon. We'll go down to F, and remember we had 2,614 rows. And that gives us the total interest paid. And we could have just got the sum of this column also, but we illustrated both ways to do that. The cash savings is the value of what we would have paid had we just followed the terms of the loan, and what we actually did pay on the loan, which is the value right here. So what we would have paid had we just followed the terms of the loan would be, let's take the absolute value of our monthly payment amount, just following the terms, no additional, and let's then multiply that times the loan term. That's what that would be, G4. That's what we would have paid if we just followed the terms of the loan. We have that value. So let's subtract from that the total that we paid on the loan, and that tells us what we saved by accelerating our payments just a bit. And in the same way, let's calculate the time. So we took out a 30-year loan. Let's see how long we actually paid on this loan. And this is measured in years. Now remember, if we have yearly set here, then it's going to look a little differently. So we're going to want to take the original loan term and subtract from it the actual loan length now in years, which in this case they match up. However, if it's set to anything else, that loan length in years is going to be one row lower. So we're going to need to take the original loan term in years and subtract it from the loan length in years as a result of our payment plan. So we'll take a look again and see if the value in D5 equals yearly. If it does, then we'll go ahead and take D4 and subtract it from the number of years we actually paid on the loan, which would be right here. If it was years, this would say loan length in years. That would be the calculation. But it doesn't say years, so we're going to take the loan term in years and subtract it from the cell where loan length in years is calculated for all other payment periods. That's G6. We'll close that off. And that tells us that we saved 6.42 years by paying a bit extra on the loan each month. Now let's calculate the discount points associated with this loan. And in this calculator, we're just pointing over here to the interest rate that we're paying and assuming that this is our target interest rate. In reality, you may want to just put an interest rate value in here so that you can experiment with that. But for now, we'll just leave it at this. It just makes it a little bit easier, one less step. So we need the amount paid for points. And if you remember from the lecture, points normally cost 1% of the loan amount at times the number of points that you want to purchase. So let's take 1% of our loan amount, which would be our loan amount, times 0.01, and then we'll multiply that times the number of points that we want to purchase, and we get $1,500. Now the interest rate without points, we're simply going to take the interest rate that we're using and add to it the number of points we purchase, how much they lower the rate. So we'll take our value here and add to that. Go ahead and calculate the number of points we're purchasing times the amount that it lowers the rate. We'll assume that this was the rate we started with, and by purchasing the points, we lowered it to the new discounted interest rate. All right, so that means it would have been 5.25, and you can see that here. Now we need to calculate the actual payment without points, and that's a little challenging because we are using a different interest rate. We can't just look over here and use our periodic interest rate because it's based on the discounted interest rate. We want to use this interest rate. So I'm going to walk you through a little exercise that we've talked about in class where we calculate a difficult portion of a function in another cell, and then we just copy and paste it in there because we want to use the payment function in Excel like we used over here. And you can see when we do that, we need the interest rate, we need the number of periods, we need the present value or the principal amount, and then we need the type to know if it's beginning or not. And we'll just use the same that we used here so that we can compare back and forth. But we need this rate, and we have to calculate it within this function. So I'm just going to calculate it up here. Again, we're going to go back and take a look at the period that we selected. So if in the period section here we selected weekly, then we are going to take the value in cell K6, our interest rate, and we're going to divide it by 52 weeks in a year. And we're going to divide it by 52 weeks in a year. Otherwise, we're going to use another if statement. Let's say if, and if the value in D5 equals biweekly, always careful to spell these correctly, then we'll take the value in K6 and we'll divide it by 26. Otherwise, we'll check again to see if the value in D5 equals monthly. And this is going to wrap because we're running out of space on the screen, but you can kind of follow it around. If that's the case, then we're going to take K6 and divide it by 12. If it's not the case, again, we'll take take the value in D5, and we'll look to see if that is equal to quarterly. If it is, we will then divide it K6, place K6 over 4. And if it's not any of the above, then we know the interest rate was annually, and we'll just take the value in K6 because that is the annual interest rate, and I'll just close this off with parentheses. You can see now that I have the correct interest rate. It's pretty close to this interest rate, and these values are pretty close. Now, the challenge is to copy this into this payment function. I'm going to show you a little trick in Excel because if I just copy this, these are all relative cell references, and so they're going to move. Everything's going to change. It's going to cause a problem. So I don't want to just copy it. What I want to do is go up into my formula bar, and I want to highlight this value. Then I want to copy that, and I'll copy that by doing Control-C to copy. That copies it. Now, very important, I have to press Escape before I can continue. All right? Now, this text, the text of this formula, is copied into the clipboard. So now I can go ahead and do my payment equals payment and ask for the rate, so I can do a Control V and it will paste that in there. Great. So now it's going to give me the rate, then comma, the number of periods. Well, the number of periods, now that's okay. That's going to work. I can go ahead and select my number of periods over here in G4. That's going to be the appropriate number of periods given the payment period that I select. And then I can go ahead and give it the present value, which is the loan amount. That's the same everywhere. We're not doing a future value. And for this, we're going to do what we did previously. We're just going to use the if statement to take a look at what we selected. And if we selected beginning, then we're going to set that to a 1. Otherwise, we'll set it to a 0. Close off our parentheses. And then we want to be sure to include any additional payments that we might have decided to make. We want these to be comparable. So we've decided to, in this case, increase our monthly payment by $100. Close that off. And we have our payment amount. And now that we have that, we'll go ahead and just delete this. We don't need this any longer. Monthly savings with points. We'll take the value in cell D9, which represents the actual monthly payment that we make, and we'll subtract from that our new monthly payment in K7, and that will show us that we're with points. We're going to save $23 a month in payment. And to calculate the total savings from points, we'll take the value above us here in K8, and we'll multiply that times the value in cell G5, which is the loan length. We actually paid on the loan given our payment options. Shows us we'll save over the life of the loan $6,530. Now, net cash savings from points. Of course, we had to buy the points. So we'll take our value in K9 that we just calculated, and we'll subtract from that the value up here in K5, which shows us how much we paid for the points in the first place. So we take that off. That was a cash outflow. So we need to factor that into our savings. The monthly break-even in points, we'll go ahead then and take the value in K5, which is the amount that we paid for the points, and we'll put that over the value in K8, which is the monthly savings in points. It tells us how much we saved each month. So by dividing those out, we find how many months until we've saved at $23 a month our $1,500, and that'll be 65 months. And for this value, we're going to need to find what portion of our loan term this represents. So we're going to do a calculation here. Remember that if the user is selected yearly, this will be the answer. This line won't be here, so we need to eliminate it. So we're going to take the value in cell D5, and if it equals yearly, we'll set this cell to blank. Otherwise, we want to take a look at D5, and if it equals weekly, we're going to take our loan term in years and convert it to weeks, 52 times 52. If not, we're going to take if and then the value in D5 and see if it equals bi-weekly. If it does, then we'll take our value in cell D4 and convert our loan term to bi-weekly periods. Otherwise, we'll if and the value in D5 equals monthly, then we will take our value in D4 and convert it to months. At this point, since we've already eliminated yearly, quarterly is our last option. Here we will convert D4 to quarters. So we have that. We'll go ahead and close off our parentheses all the way back to just before the end. Because remember, if it's yearly, we're not going to do anything. So we're part of a nested if statement here. So at this point, we need to divide by K11, which is our months to break even, and then we'll close off our if statement. There we go, and then press enter, and it shows 5.54 years to complete this loan. That completes the amortization project worksheet.